Hello everyone, welcome to our first YouTube video. A little bit introduction about me. I'm Mohsen and I'm a mechanical engineer here in Canada, and I work in a food and beverage industry. So everything is going good. Having studied math and physics, I thought, okay, you know what, let's start a YouTube channel and give or provide some educational content. So now I'm going to be starting off with physics, and let's dive into it. So let's start off with what physics is. So let's start off with general physics. So general physics is basically something that's going to cover things like Newton's law, right? Of motion, of forces. You basically run into something like kinematics. You run into something like dynamics. But what is this? So kinematics and dynamics is something which comes under the terminology called motion, right? And when I say motion, it basically means something related to apparently speed, something related to velocity, something related to distance. Why? What is that exactly? So let's think about it for a second. Motion is basically something that's not static, or something that is not in a standby mode. So if I have this pencil like this and it's straight, it's static, it's not moving, hence it's not in motion. But if I start to move this pencil from this point to this point, so now it moved, right? Hence that it was in motion. But what is motion exactly, and what physics terminologies that I end up using when I moved it from point A to point B? So when it's at point A and I go to point B, it actually travels a certain distance. But obviously when it is traveling a certain distance, it's taking time, right? So point A to point B, maybe 1 second, right? So when I say motion, again, time is involved. Now, if you look at this pencil, I'm moving it from point A to point B. It's going with a certain speed. But if I do it like this, the speed increased. Or if I go super slow, the speed has decreased. So that's why something like speed comes into play when I say the term motion, right? And there are further terms like displacement, there are terminology like acceleration, but we're gonna look into it later. There is measurement, which is what we're gonna be starting off with. That's gonna be our first topic in physics. This is gonna be our first topic when you start physics. But what is measurement? It basically defines those quantities that are going to be used later in the harder chapters of physics. Quantities like what is volume, what is length, what is density, you know, things like those. So a good thing about my videos is that when I'm going to be teaching you these things, there's going to be some visuals that are going to be on my videos, so you guys can see those while we're solving questions or we're discussing these problems, so you can visualize what really is happening. And then we go into Newton's law, which basically involves something like forces, you know, so things like those. So what exactly is a force? We're going to look into it. But to give you an idea of what really force is, let's suppose this right here is a block with a certain mass, and now you have to, this right here is a human being which comes and pushes this. So when that human being pushes this block of mass is obviously gonna go from point A to point B, right? So let's suppose this is point A and let's suppose this is point B. So it ended up traveling a certain distance, right? And when it ended up traveling a certain distance, obviously it ended up traveling the distance at a certain speed. And if it traveled at a certain speed, obviously there's going to be some sort of acceleration or deceleration, which is something we're going to be studying later. And that thing ends up becoming a force. Why? Because what force is force is equal to mass of anything, like in this case the object, multiplied by the acceleration at which the object ended up moving, right? So we're going to look into what this is. It's still a question mark. I'm not going to go into much details. I don't want to confuse you guys. But there are lots of things in physics, but what physics is really. But physics is basically the study of why things are the way they are. For instance, why is the sky blue, right? Why is the apple falling from the tree? We all hear that example of, hey, the apple fell on Newton's head and there you go. He discovered gravity, but why? How? Things like those. So we're going to be looking into it. We're going to be diving deep into these basic concepts and then the harder ones. But then again, it's not only about if I make you guys good enough to pass the exam, because I really don't want to do that. If you're only watching these videos for the sake of passing the exams, please don't, because I want to dive deep into the world of physics with you guys, and when we come out, you're actually a physicist. That's what I'm aiming for. You know stuff. You know why the world works the way it's working, right? I don't want you guys just to do it for the sake of passing your exams. Okay, anyone can do that. So these things are the basic of physics. And okay, then let's start off with our very first chapter, measurements, right? So what exactly is a measurement? Let's start off with the most basic one. Let's suppose we talk about length, right? Now, if I talk about length right here, what length is really? So again, I'm gonna go back to that basic example of this pencil, that from point A to point B, has traveled a certain distance, right? So length really basically is in easy terms, it's called distance. As simple as that. So distance and length are very interchangeable terminology. So from point A to point B, if a human being or a car or a machinery or an airplane ends up traveling, that thing ended up traveling a certain distance, right? And that distance is basically called length. So what is length or what is distance? They are basically so length, okay, to give you a definition, right? Length is basically distance traveled between two points in a story. That's it. And obviously, when you're doing math or physics or even chemistry, you need to know what the unit of measurement is. So the SI unit in this case for that is meters. But why? So I feel like this is a basic thing that we know, because ever since you guys were born, and ever since you've been talking, whenever you hear someone talk about how far that place is, you either tell someone that, okay, it's 5 kilometers from here, or in North America you say it's 5 miles from here, right? So distance is a certain unit, and if you talk about the system international unit, that's meters, right? But obviously it could be converted into things like kilometers or centimeters, depending on how far or close the object really is. Because if you're measuring the length of a paper, you're obviously gonna say, okay, it's 10 centimeters or something like that, because it's not that large. But if you're talking about the distance from point A, let's suppose the distance of Canada to US, that's something you can't really define. You can define in centimeters, but that's out of the norm, right? So you're gonna bring kilometers into the equation, and that's what happens. But to give you an idea, this SI unit is meters, but then again, distance could be the other units you could use in this case are centimeters and kilometers and millimeters, depending on how far or how close the objects or the distance really are. So that's basically what length is. Let's talk about volume, right? So what's volume? So the simple definition of volume is basically the space occupied by an object. So if you think about it, I'll give you an example of, let's suppose, water here, right? So before we go over there, think about it this way. When I talk to you about how many gallons or liters of water did you drink today, why am I asking you liters or gallons? Because this is basically something we use. I never asked you how many liters of water did you drank today, right? So the unit, hence, that is used for the case of volume is basically meter cube, or you could say liters, right? So multiple units that are used for volume, but the SI unit is again meter cube. Now, if I add some water into this container, let's suppose this is half full, so you could say it's half liter, right? But then if I add more water into it, so the water gets, now you could say that okay, it's 1 liter, so it's full now. So it really depends. That's basically what, but if you see, the water is something that is occupying the space of this container, hence proving the definition that volume is the space occupied by an object, in this case water. So that's basically what volume really is. Now, this something is an exam question that I'm going to discuss with you. That does come, and that's why I'm going to highlight it that way. But this is something we're going to look into because this is something very important. Imagine you have a rock, something like this. Now this rock obviously will have the volume, right, in meter cube. But how are you supposed to find it? So just go back to the basics, and the basics is that volume is something that it's basically the space an object occupies, right? So let's use that same formula for this rock. So think about a container over here and fill in some water in this, and the water that you end up filling in is, let's suppose, half liter, right? Or you know what, instead of that, let's say you ended up with 20 meter cube. So this is basically position A, and then you ended up adding a rock to the existing water, and obviously the water level is going to rise up to this point, but now there's a rock to it, and let's say this is position B. Now this right here is 50 meter cube, right? So water level rises. So what is the volume of the water? It's very simple. The volume of the water, so this is, let's suppose, V2, and this is, let's suppose, V1. So the volume of the water is the change in volume, that is V2 minus V1. Hence in this case 50 minus 20 meaning 30 meter cubes. That's as simple as that. So this is a very simple question that's going to come in the exam, but really you guys would need to know what's really happening here and how can you measure what volume really is. So let's look into it in more detail. I have a question. Think about a rectangular block of wood, something like this. So this is a rectangular block of wood, right? And it has dimensions like 240 millimeters, 20.5 centimeters, and 0.404 meters. There you go. We need to calculate its volume. So how do you do it? So it's very simple. This is basically math, and the volume of a rectangular object is length times breadth times height. So it's basically 240 mm multiplied by 20.5 centimeters multiplied by 0.04 meters, and then you just multiply, right? But no, because when you talk about measurements, something that you need to understand is that whenever you're multiplying or dividing something, and even adding or subtracting, so whenever you're doing an arithmetic or geometric calculation to it, and this is very, very important, the units must be same. If they're not, well, you're getting it wrong. It's as simple as that. Why? Because if I'm adding 500 kilometers, so let's suppose I say that, hey, I have to travel 500 kilometers, and someone named Sam says I have to travel another 30 centimeters, right? So if I add 500 plus 30, is that 530 kilometers? No, it's not, right? That's actually 500 kilometers and 30 centimeters, which is completely different. So what you need to do is you need to convert these units into one. So the 240 millimeter becomes this much multiplied by 20.5 centimeters becomes this much. Multiplied by 0.04 meters, and then you use your calculator to get your answer in meters. That's how it is. That's basically how simple it is. So yeah. Which brings me to my next point, which is conversions of units, right? Now, when I talk about conversion of units, it's again very simple. The SI unit in our case was, let's suppose, meters. So 1 kilometer is equal to 10 to the power 3 meters. 1 meter is obviously 1 meter. 1 centimeter is basically 10 to the power minus 2 meters. 1 millimeter is 10 to the power minus 3 meters. And 1 micrometer is 10 to the power minus 6 meters. And 1 nanometer is 10 to the power minus 9 meters. I believe there's a deci as well somewhere in. But if you grasp this, the conversion is going to become easy for you. So again, very important. So this is just a conversion. Again, all you got to do is multiply these things. If your math is good, you're going to be fine. So that's basically the start of physics, and this is my first video. In the next one, we're going to be discussing about what precision and measurement is, and things like a ruler and a micrometer screw gauge and a vernier caliper, and when do they come into play. And then we're also going to be learning about what density is. So in the next video or chapter, we're going to be learning the basics and completing this chapter, and then we're going to be moving on. But if you like this video, please be sure to subscribe and share and comment. But then again, I would suggest that if you're only looking to pass your exams, this video is not for you. But I'd rather work with you guys to explain you all the concepts of physics in detail, and then we go together as physicists, right? And that's what my aim is. So thank you so much. I'd appreciate all the love, and it's gonna be you guys who are gonna decide if more videos are to come, because if I get support from you guys, definitely gonna make more and gonna make your life easy, and we're gonna have a lot of fun. So thank you so much again, and take care. Bye.